For a brief introduction to the Gamebryo entity system. The scene graph is composed of NIAV objects, which are all things that are relevant to the renderer. Now, render is important, but it's not the game. Entities are objects that are relevant to gameplay. Most entities contain scene graphs, whether this is one character, one object that's decorating your game, or an entire game level. But the gameplay logic usually thinks about entities rather than nodes in a scene graph. In the entity layer of Gamebryo, we support multiple inheritance through interfaces. So any entity is a thing with properties. It also has an error reporting interface and a command encapsulation interface. By bundling commands up as objects, we have strong support for undo and redo in all of the tools in the entity system. By bundling up error reporting as a separate side of an object, we can have uniform error reporting, essentially aspect-oriented programming across the Gamebryo entity system. An entity is a thing with properties, and it can contain many components, each of which is a thing with properties. Entities or components support reference counting, but not through the Gamebryo NIREF object system, because this is a different inheritance hierarchy. Similarly, there's some RTTI support, but not the standard Gamebryo scene graph layer runtime type identification. So properties are individual pieces of data in gameplay objects. These all support reflection. You can write code that asks an entity or a component, what properties do you have? And because every property has additional information, tools can get at this additional information. Every property has a primitive type. Is this a float, an int, an array of floats, a string? A semantic type. What's this array of floats mean? Is it a position, or is it a normal, or is it a color? A display name, some human readable text. A description, which is also longer human readable text that a tool can display as a tooltip, etc. So every tool can automatically query an entity or a component, figure out how to build in code an editor for that entity or component without you having to write any specific code for that particular object. So an entity system can be used across any sort of game. You say, I need an entity, it has this component, and all of the tools that work with entities will instantly know how to display it, how to let you edit it, how to read it in, how to save it back out. Properties can also contain collections of values, and they can be shared between components. An entity is a flat collection of components. There's no hierarchy internal to an entity. Each component is a small bundle of properties. The difference between it and an entity is that components don't exist by themselves. They only exist as part of an entity. Typical components are a transformation, which in Gamebryo means a translation, a rotation, and a scale. A scene graph. The critical part of the data there is the path to a NIF on disk, which can be loaded to instantiate that scene graph. A light, a camera, a path to a KFM file, which, if loaded, gives you an animated actor with both geometry and animations. A path to a SPT file, which, if you have SpeedTree, can be loaded to give you a SpeedTree forest. A path to a terrain object, which will give you landforms in Gamebryo. An entity can have any subset of these or other components, including components that your game creates. Some of these components can depend on other ones. For instance, both the actor and the scene graph depend on a transformation. An entity that has a scene graph component must also have a transformation component. That way, the system as a whole knows where to place that entity scene graph in the world coordinate system. So for instance, if you had a single entity that held your level geometry, there would be some terrain, perhaps. There would be a forest, perhaps. Maybe some fixed cameras, some fixed lights, some static geometry in a scene graph, and a transformation. An entity that held a character would have a transformation, a scene graph for that character's geometry, and bones and skinning data, and an animated actor, the KFM that has all the character's animations and how those tie into the bones and the skinning. You can find plenty of examples of this in EGT Path samples, models, scene designer examples. And all of those examples can be loaded into Scene App, our shell application that loads entity system data files.